Hello everyone, I'm Subhasree. I am from Techno India College of Technology. My topic is functional dependencies in DBMS. First one, what is called DBMS? A DBMS means database management system. That is a collection of programs that enables user to create and maintain a database. It has several criteria like management of large quantity of structured data, efficient retrieval and modification like query processing and optimization, sharing data like multiple users can use and manipulate data. And fourth one is the maintenance of the data integrity. Okay, now the architecture of a DBMS. It consists three level of architecture. First one is called external level, second one is called conceptual level, and third one is called internal level. External level defines the actual storage of the data. Conceptual level consists the main functionality of the DBMS. And internal level interacts directly with the users. The structure is given below. Okay. Okay. Second one is the data independency. Data independency means the ability to modify the schema definition in one level without affecting a schema definition in the next higher level is called the data independence. There are two types of data independency. First one is logical data independency and second one is physical data independence. The very important thing in the relational model is called null values in tuples. Okay, relations should be designed in a way such that the tuples will have few null values. There are some reasons for null values to be generated. First one is attribute not applicable or invalid. Attribute may be unknown or a value is unavailable but may exist. And second one is lossless join or non-additive join. This property ensures that no spurious tables are generated when a natural join is applied to the relations in the decompositions. Okay. Functional dependencies plays a very important role in DBMS. Okay. It helps to uh, design one yard diagram, and it is helpful to get the different kind of strategies in doing the yard diagram. Functional dependency means when a set of attributes x, maybe a set of attributes x is functionally determines a set of attributes y. If the value of x determines a unique value for y, that means it is holding one functional dependency. If I say it's more explicitly that I may say that x who tends to y means it holds if wherever two tuples have the same value for x, they must have the same value for y. That means if t1x equal t2x and t1y equal t2y in the relation in any relation instances are, it becomes it means it is holding the functional dependency. Okay. Second one is called the relational instances. That means if x tends to y in R, that means it specifies a constant or all relation instances, that means R. It means it is holding the second type of functional dependency. Third one is called if the constant must hold on every relation instances R, that means it is holding a functional dependency. If K is a key and of R and K is functional dependent on any relation, that means it determines all attributes in R. Functional dependency means it is holding different kind of dependency by which we can define different kind of relation which helps to make any strategies in doing the all kind of like data diagram or yard diagram like this. So it is very helpful to maintain one yard diagram in any DBMS system. Okay. Next one is called the inference rule of functional dependency. Different type of function inference rules of functional dependencies are available. First one is like Armstrong's inference rule. Okay, Armstrong inference rule means three main important Armstrong rules are there. First one is reflexive, second one is augmentation, and third one is transitive. Reflexive Armstrong inference rule means if y is a subset of x, then x tends to y, it is called the reflexive. Second one is called augmentation. If x tends to y and xz tends to yz. Here xz means x is called union with z, and transitive means if x tends to y and y tends to z, then it is called x tends to z. So these three type of Armstrong inference rules are there. It is called the different types of Armstrong rules in DBMS, and it is very helpful in making the strategy in functional dependency. Okay, there are some additional inference rules out there. Okay, first one is called decomposition. Decomposition means if x tends to yz and then x tends to y and x tends to z, this is called decomposition. Okay, next one is union. If x tends to y and x tends to z, then x tends to yz, it is called union, because here the x tends to y and x tends to z and yz is become union with the functional dependency of x. And last one is called pseudo transitivity. Okay, in pseudo transitivity, if x tends to y and wy tends to z, then yx tends to z. It is called pseudo transitivity. These are some additional inference rules out there, and the set of all dependencies that includes f and all dependencies that can be inferred from f, it's called the closure of f, and it is denoted by f plus. This type of closure additional inference rules helps to build the functional dependency more explicitly way, to help any strategies making out to do the any kind of BR diagram or any kind of uh, DBMS management system. Okay, now I'm coming the main part, that is called normalization. Normalization is the process of recognizing data in a database so that it meets two basic requirements. There is no redundancy of data, that means all data is stored in only one place. Data independence are logical, all data items are stored together, and normalization allows database to take up as little disk space as is possible. So it increases database performance. Normalization is also a data normalization. There are different types of normalization forms are out there. First, 1NF, 2NF, 3NF, BCNF. Okay, and normalization is a process through which we can make out the different type of relations in the relational model. So I am now, it is the first normal form. The attributes value permitted by 1NF are single atomic. Okay. First NF means atomic, means all the attributes should have uh, one super key. Okay, and here one example is example is out there. It's an example of department. Here D name is there, D number is there, D manage MGR mean the management number, and the locations are out there. Here if you notice, then the dname, dmgr, ssn and d locations is fully dependent on the d number. Here d number is the super key or the primary key. So all the others non key attributes should be dependent on the main key. So it is called the atomic structure. Okay, second normal form. Second normal form means if it is said that if a relation schema R is in the second normal form, then if every non-prime attribute A in R is fully functionally dependent on the primary key. Okay, that means here the other example of one employee project. Here SSN, P number, hours, ename, pname, and P locations are out there. So first one, FD1 is dependent on hours. Here SSN and P numbers are called the SSN in primary number, SSN in primary key, and P number is a candidate key. So P number and SSN is both is dependent on hours. So here first NF is there. In every two, that means the functional dependency is 2 in 2. In the next functional dependency, ename is fully dependent on ssn, and in fd3 the p location and p name is fully dependent on fd3. And in second, if we divide this entire normal form into second nf, then the ep, we will get the EP1, EP2 and EP3. If you notice that in EP1 the P number and SSN is dependent on the hours is dependent on SSN and P number, ename is dependent on SSN, and P location is dependent on P location, and P name is fully dependent on P number. So here we have found three different types of functional dependency. This is a third normal form. In third normal form, a relation schema R is in third normal form if it is in 2NF and no non-prime attribute A in R is transitively dependent on the primary key. That means here is another example of AMP department. Here ename, SSN, bdate, address, D number, DNAME, DMGR, SSN are out there. If we divide this entire location into 3NF, then we will get two kind of normalization form. One is called ED1 and second one is ED2. In ED1, ename, SSN, bdate, address, D number out there. Here ename, bdate and address and D number are fully dependent on SSN. And in functional dependency 2, the dname and dmg are SSN fully dependent on D number. So here we have seen that this entire normal form, if every non-prime attribute is transitively dependent on the primary key, but here is no transitive dependency. So each and every non-prime attribute is fully dependent on the primary key. Here is no transitive dependency, and one more thing is there. Here it is already in its 2NF. So we may say that if we get any normal form in 3NF, then it is already in 2NF. Okay. So next one is called BCNF. Its full form is Boyce-Codd normal form. A relation schema R is in BCNF if whenever a non-trivial functional dependency X say holds in R, then X is a superkey of R. Here is a another example of one property ID, country name, lot and area. Here country name, lot and area is fully dependent on the property ID, and area and property ID is fully dependent on country name and lot, and in 85 the area is dependent on the country name. If we divide this entire dependency in BCNF normalization form, then property I will get two different type of dependency. One is called um, in first normal form, the area and lot is dependent on primary property ID, and country name is dependent on area. So we have noticed that here there is no non-trivial functional dependency, and if it holds, then one thing must be superkey of another. So we may conclude by saying that normalization theory provides a mechanism for analyzing and refining the schema produced by a near diagram, and it provides a set of guidelines but does not result in a unique database schema. That means in every normal form that you have found that each and every non-prime attribute must be dependent on the primary key. So using functional dependency, we may using different kind of functional dependency, we may find the different type of transitive dependency on primary key. So another thing, the attributes value that we are using in by doing the functional dependency, we may uh, we may use those concepts in doing the yard diagram, and each of the in each of the every normal from like first NF or second NF or third NF or every NF, it is must essential that each and every non-prime attribute should be dependent, fully functionally dependent on the primary key. So here are some more references, like I have found the entire help through the fundamentals of DBMS management system by Navate and Elmasari, and the other book which is very helpful and dependent on it is called COT, and these are the links through which I have found the entire help, and it is very helpful in making me the entire concept. Okay, and it is very interesting to do the entire PPT. I've enjoyed much, and normalization is a process that provides a mechanism to analyze and defining the schema produced by ER diagram.